This is AP Calculus AB, self-check 9.1. All right, so we have our zoo question, and it's asking us to approximate the rate at which entries were being deposited at time equals 6. So we're looking for a rate, and we're doing computations. Okay, so the rate means, if this is hundreds of entries, then the rate is really the derivative. So it's e prime of t. It's not e prime of t because we're actually taking time equals 6, so it's e prime of 6. So e prime of 6 is going to be approximately equal to, well, we don't have a 6, so we have to approximate using these two values. So I'm using these two entries and these two entries to approximate. So it's really going to be e of 7 minus e of 5. I'm using this secant line to approximate the tangent. And that's going to be divided by 7 minus 5. So what is that going to be? So e of 7 is 21, e of 5 is 13, minus 13. All of this is going to be divided by 2. So that's going to be 21 minus 13, that's going to be 8. 8 divided by 2 is 4. So this is going to be 4. And our units here, it's the derivative here, so it's going to be hundreds of entries per hour. So 400 entries per hour. Perfect. Okay, part B, use trapezoidal sum to approximate this thing. Okay, so we have 1/8 of the integral from 0 to 8 of et, capital E of t, dt. Okay, so to approximate this with trapezoidal sum means that I am taking this distance. This is going to be the height of the trapezoid. That's going to be a distance of 2. And then I need to find the average of these two values. So I add them, 0 plus 4, and then divide by 2. So that's going to be 2. The average between 0 and 4 is 2. So I say the height is 2, the average of the bases is 2, so it's going to be, I have to copy down my 1/8, and then I'm going to say height, or base times height, and I do the next one. So it is from 0 to 8. I just want to make sure I got the interval correct. 2 to 5, so that's a distance of 3, so a height of 3. And then the average of the bases, 4 plus 13 divided by 2, that's 8.5, 8.5. So this is going to be 3 times 8.5. I guess I'm doing the bases second here. And then plus, this is going to be a distance of 2, so that's the height. And the average of the bases here, 13 and 21, that makes 17 after I divide by 2, because I got 34. And this is going to be, so 2 times the quantity of 17, and then finally our last value from 7 to 8, that's just 1. 1 times the average of those two, that's just 22, right in between 22. Alright, so now to approximate this thing, I'm going to go to, actually I can go right here. So I have 1/8 still, and then when I multiply all these together, this is going to be 4, this is going to be 25.5, this is going to be 34, and this is going to be 22. Add all those up, that's 85.5, so that's 85.5. And when I divide that, I should get approximately, maybe I should go to the next line because I want units also. So this is approximately 10.688. And that is going to be 100 entries. 100 entries. Alright, so now we're kind of after the voting has begun. So at 8 p.m., this is when, in the context of the problem, from 0 to 8 is when they enter votes. So now at 8 p.m., now they're going to start counting, start processing the votes. Alright, and the process at this rate, so now this is a rate, PT, this is a positive, well, I guess it's technically a negative rate because they're getting rid of votes now. So this is a negative rate. So the number of entries is going to go down with this rate. And it goes between 8 and 12, so it takes 4 hours to process the votes. According to the model, how many entries had not been processed? Okay, well, how many did they start with? And then we'll get rid of those with our negative rate. So they started with, right here, so they started with 2,300 entries at time equals 8, and then they're done. So we want to say everything in here is in hundreds of entries, so we're just going to say 23. We don't have to say 2,300. 23, and then we have to subtract this negative rate. So we have to subtract P of t. And since this is a rate and this is just a number of entries, we need to take the integral of this to get back from a rate to the number of entries. So we have to take the integral, and our bounds are now from 8 to 12, so from 8 to 12 of p of t dt. And now we have to actually calculate what that is. So I'm just going to use my calculator here. Alright, so y equals, and we're entering our equation, so it's x to the power of 3 minus 30 t squared plus 298t minus 976. And we don't even need to graph this thing, we just want to second quit. We want to just find the integral. So math 9 integral, I guess I should have done 23 minus this. Let me back up here. Let's do 23 minus math 9, 23 minus the integral of, oops, not 10, of vars right, enter, of y1 with respect to x from 8 to 12, and yeah, that'll just pop out a number. Oh, it's exactly equal to 7, so it is equal to 7, and let's not forget our units here. So by midnight, we still have 700 entries, so 100 entries. 700 entries left. So they didn't quite finish at midnight. That's unfortunate. According to the model from part C, at what time were the entries processed the most quickly? Justify your answer. Okay, so for this one, we need to actually, this gives us the rate. So we're just looking at where is this rate the highest, and I guess it's a negative rate, but we're just going to look for the highest, so we need to check endpoints and check critical values. So let's check our t. And we're not doing start plus change equals n. We're just plugging in values to see where is this thing the highest. Is it highest at 1? We plug in 1, see how big that number is. We're looking for the biggest number here. So I'm doing t and p of t. All right, so obviously I need endpoints, 8 and 12, and we need critical values in here too. So how do we find critical values? Let's graph the darn thing. Oop, no, go back here. Okay, I messed that up. There we go. So we need to graph this thing. So our window is going to be now from 8 to 12, and we'll hit zoom 0. Again, we don't need the 23 in this graph just because we're just plugging in values. So it looks like that value here, those are the two critical values. Really, we only need to check that one because that one's obviously lower. We can include it in the table just to prove that it's lower, but we, again, don't really need that. How do I find that point? So I could graph the derivative. I could come back to y equals and then take the derivative and graph that. But there is a way to do it with the calculator immediately. So in this graph, if you do second calculate, you'll notice that there's a maximum function. So if I hit 4, the maximum, I want to find that point here. So I'm going to say my left bound. Remember, this is 8. So I'm going to say between 8 and, I don't know, 10. So between 8 and 10, and anywhere in between there, 9. And it says the maximum right there is at x equals 9.184. So 9.184. And oh, it tells us our y immediately. Let's just log our y, 5.089. 5.089. And I guess I can find this one too, just to show you how this works. We can find a minimum here too by doing second trace, and minimum is 3. So this is 8, 9, 10, so let's go between 10 and 12. How about 10 and 12, and anything between there, 11. And our minimum is right there, 10.816, 10.816, and yeah, it's obviously lower, it's 2.911. 2.911. Didn't really need that value. Now let's go ahead and find 8 and 12, so I just hit trace, and I type in 8, and it says, oh, yeah, it's 0. That's definitely low. And at 12, y is equal to 8. All right, so we're looking for, again, in this problem, where is it the highest? I think it's pretty clear, just without even doing a table, that it was at time equals 12, it is the highest. So we need to say that the entries are being processed most quickly, and at, just looking for a time, right? at what time were entries. It doesn't care about what the rate of those entries were. This shows our work most quickly at t equals 12 hours. All right, let's go back and score this thing. So there were 9 points here. So in part A, this was out of 1 point. If you got 4, you get 1 point. So that's +1 if you got the 4. For part B, so using trapezoidal sum, so you get 1 point if you're able to get this thing here, this long string of numbers. If you're able to get the approximation, so at 10.688, that's +1. Oh my gosh, and we did not finish part B. I apologize. So we missed a point, Mr. Sandell. We were 8 out of 9. So we forgot the second part, using correct units to explain the meaning. So I'll just do that up here because I ran out of room. So sorry about that. So the meaning, we could say that 1 over 8 integral between 0 and 8 pt dt. That means, and it's really in this lesson, it's between total and average. So this is the average value, means average value, and it's the average value of this function, average value of capital E of t dt, and that's our units are in hundreds of entries. Hundreds of entries. And that's from 0 to 8 hours. Okay, now I get full points by having that explanation, so sorry about that. So that's another +1 if you have the explanation. You really need average value. That's the key thing here. It doesn't mean total. All right, so that problem was out of 3, and part C, that's going to be out of 2 points. So you get 1 point if you have this integral, so +1 there, and then you get 1 point if you got the answer of 7. And part D, that is out of 3 points to add up to 9, and you do actually need to have at least one of these values. So if you have one or both of them, that's +1. You have those as candidates, and then you have to have identify as candidates. So I think you have to have, I'm going to say that if you have 8 and 12, that's another +1. So if you have n points, and if you have the answer at time equals 12 right here, that's +1 as well. All right, and now on to cell check 9.2. And if you're wondering where this problem was taken from, it doesn't say on our worksheet. It is taken from the 2008 practice test, which you need a administrator account or something through through the AP Central. So that's how I got this one. All right, so temperature, using data, looking for instantaneous rate. So we're looking for a rate, and at time equals 10. So it's very similar to the last problem. We're just looking for, our function now is h, so h prime of 10. And that's going to approximately be, so we're looking at 8 and 12, because those are the points on the outside. So it's going to be h of 8, sorry, not h of 8, h of 12. We want to do b first, minus h of a, which is 8, all over 12 minus 8. 12 minus 8. And again, if you switch these, so you do 8, h of 8 minus h of 12, and 8 minus 12 on the bottom, you'll still get the same answer. So when I do h of 12 is 80, minus 73, all divided by 4, and that's just going to be 7 over 4. And you can just leave it as a fraction. 7 over 4, our units are degrees Celsius, and then per minute. All right, part B. So we need an average temperature first, and then after we find that, then it's going to ask some more stuff. So how do I find average temperature, the average value? So average temp, that's going to, well, it's not going to be approximately, it is the integral, 1 over 16, integral between 0 and 16. This is just the definition in our notes, by the way, of h, capital H of t dt. And that's the definition of average, and in this table, that is our average. All right, and then now we want to approximate that average. So to approximate, we're using a left Riemann sum. So left Riemann sum makes this shape. Okay, so our width for our rectangle, our base for the rectangle is 4, because that's a distance of 4, and then we multiply by the height of 65. So you'll note that we are going to be using all of these values right here. We're not going to be using the 90. All right, so let's go ahead and set this up. So we want to say that 1/16 of 0 to 16, this average temperature, capital H of t dt, that is approximated by, we still need that fraction, 1/16 of, and I note here that all of these gaps here, this is a gap of 4, this is a gap of 4, this is a gap of 4. Since all the gaps are the same, instead of saying 4 times 65, 4 times 68, 4 times 73, 4 times 80, I'm just going to bring that 4 on the outside. I'm going to say 1/16 times 4, and then I'm just going to add up all these heights. 65 plus 68 plus 73 plus 80. All right, and notice that 4 over 16 reduces to 1/4, so this is going to turn into 1/4, and add all of these up, that should be 286. So 286, and then 286 divided by 4 is about 7, it is exactly 71.5, and our units are, so average temperature, this is the temperature, so the average of the temperature is degrees Celsius for the correct units. Perfect. Okay, on to part C. Is your approximation part B an underestimate or an overestimate? Okay, so this is the one where you just have to either have the rule memorized or do a rough sketch. I'm going to do a rough sketch just to make sure I know what I'm doing. So we have our graph. Maybe I should make this line a little bit farther to the left. We have our graph, and are the values increasing or decreasing? So all of these are always going up. They're always increasing. So I have value here, value here, value here. You only really need 2, I guess, to get your table. And then from there, we have a left Riemann sum. So our left Riemann sum looks like that. It goes to the right from the points, goes to the right, and ends right there. Okay, and then the actual function that we should have been looking at kind of looks like that. So it looks like it's left Riemann sum, it's under, so it looks like it's an under approximation just by this picture, because there's this blank area here that we're not accounting for. All right, so to answer the question, so the approximation using, we use a left Riemann sum, using left Riemann, is it IE? It is IE, IEMA Riemann sum is an underestimate. And you basically just have to say, because h of t is strictly increasing, strictly increasing. And on what interval? Our interval was between 0 and 16. Strictly increasing on that interval that we're given, 0 to 16. Perfect. And then finally part D. Part D was tricky. So it's talking about increasing at an increasing rate. Is that consistent with the table? So what I'm going to do, and I can only do this because I have a consistent distance between these values. If I didn't have that, I would have to find the slope of each of these values and say that the slope is gradually increasing. But because these are all the same distance apart, I can do a little trick here. So I'm going to rewrite these values down. So they were 65, 68, 73, 80, and 90. And instead of finding the slopes in between, I just find the difference in between, because it's all going to be the same denominator. So the difference between 65 and 68, I had to add 3. 68 to 73, I had to add 5. And 73 to 80, add 7. And 80 to 90, I had to add 10. All right, so these I considered the first differences. This would be like f prime of, well, I guess h prime of t. This would be h prime of t, roughly. It's the first differences. It's kind of like the first derivative. I know that all of these are positive slopes, obviously. I mean, they're going up. And to get to the second derivative, so it is increasing. We confirm that's increasing by looking at the first differences. At an increasing rate, that's really looking at the second derivative, the concavity of it. So I can look at these second differences by doing, I'll do this in a different color, by looking at h double prime of t, the second differences. So to get from 3 to 5, I'm looking at the differences of the differences. I had to add 2. To get to 5, from 5 to 7, I had to add 2. 7 to 10, I had to add 3. Since all of these values were positive, this one was increasing. Since all of these second differences were also positive, then it's also a positive second derivative. So you're really looking at the positive and negative. If one of these was a negative, then you couldn't really say. If one of these was a negative, then you couldn't really say for the increasing rate. So just using this trick, we can say that it is consistent it is consistent. And this is because, so we'll say because first differences, I guess I should do first differences in red because that was our red values, but because first differences are all positive, and this thing proves that it is increasing. So therefore, increasing. And second differences are all positive. Therefore, at increasing rate. Perfect. So that's all you need to say to get your points for part D. And again, I want to make this clear. If these are not the same distance apart, if this one was 3, then 2, then 1, and then 3 again or something, if any one of these is not the same as the rest, then what you have to do is you have to compare the slope of each of these. And remember, slope is the change in y over the change in x. And you have to say, okay, the slopes are all positive, and then you have to check that the slopes gradually increase. It goes from like 1 to 2 to 3 to 4. The slope gradually increases like that. So check that they're positive and that they're increasing, judging by their slopes. That's a lot more work, and I didn't want to do that, so I kind of did this trick to do less work. All right, so now how do we score this thing? Everything is out of 9 points for this problem. So in this first one, you get 2 points for part A. So the first thing that you need something that looks similar to this. It can be evaluating numbers, but if you have some difference and a fraction, some difference and a division symbol, you get +1 points. And then finally you get 1 for the answer, and you have to have the right unit. So +1 if you got that answer. That's 2 points. All right, part B is out of 3 points. So you have to have this thing here. You have to have average temperature is equal to this exact thing, 1/16, or you could do this all divided by 16, but that thing for the average temperature is 1 point. Left Riemann sum, so if you have this guy down here, that's the left Riemann sum, that's +1 point. So setting up the Riemann sum is 1 point, and then actually finding your answer of 71.5 degrees, that is another 1 point. On to part C. Part C is out of 1 point. Did you get the answer? So you just basically have to say underestimate. If you said underestimate, you get 1 point. If you said overestimate, then you don't get the point. Okay, part D. So, you do need a reason also. You have to say it's strictly increasing, sorry. You do have to have that part. It's not just underestimate. All right, so for part D, to add up to 9, we have 3. Okay, so how do you score this thing? You have to consider your first and second differences. So first and second differences, that is +1. Or if you chose, you could have just looked at the slopes of each of those individual points. That would have also been another point, or that would have been the replacement of this point. All right, the second point comes from your explanation. So it is consistent. We'll say that is 1 point. You say yes, yes it is. And then the actual explanation, I guess that's the other point, +1 if you have these guys, first differences and second differences, or you say something along the lines of all the slopes are positives and the slopes gradually increase. That would be the other point.